Namaste dear students. How are you? I hope all are safe at home. Today we are going to discuss about a new chapter, very interesting chapter, that is chapter number 4, moving charges and magnetism. What is chapter's name? Moving charges and magnetism. What are the importance of moving charges? In the first chapter, you have already learned about electric charges which are at rest. But here, the charges are moving. The moving charges constitute electric current, isn't it? This electric current produces magnetic field. So, we can say that electricity and magnetism are interrelated. Or moving charges and magnetism are interrelated. Both electricity and magnetism have been known for more than 2000 years. In 1820, a famous Danish physicist, who is that? Christian Ørsted. He noticed that moving charges or electric current produce a magnetic field, or any current carrying conductor behaves like a magnet. You have already learned in the 10th standard, isn't it? After that,
in 1864,
another scientist, James Clerk Maxwell, realized that light draws electromagnetic wave. There is a connection of electric field and magnetic field. Then radio waves were discovered by Hertz and so on. There are so many experiments based on electricity and magnetism. In this chapter, we are going to discuss about the relation between moving charges and magnetism. In the first chapter, we have already learned about electrostatic force and equation for electrostatic force. Consider an electric field. This is an electric field. This is the direction of electric field. There is a charge Q. This is a positive charge. We can say that there is a force. What is the equation of force? Yes, very good. F is equal to QE. F is equal to QE. Vector F is equal to Q vector E. That is a vector form. This is the equation for electrostatic force, Fe. What is the direction of this force? You already know that. What is the direction of this electrostatic force for a positive charge? That is in the direction of electric field. In the direction of electric field. But for negative charge, this is the direction of electric field. There is a negative charge minus Q. In the same way, there is a force due to this minus Q charge, but the direction is opposite to the direction of electric field, that towards this side. So, this force is known as electrostatic force. Fe is equal to QE. This force is known as electrostatic force. In same way, in magnetism, there is a force. That force is known as magnetic force. That force is known as magnetic force. To find out this magnetic force, first of all we have to consider a moving charge. Suppose this is the direction of magnetic field and consider a charge Q. Here charge Q plus Q. It is moving with velocity v along this direction. Velocity is a vector quantity, isn't it? Magnetic field also a vector quantity. We can say that there is an angle between velocity vector and magnetic field vector. It is written as theta. Okay, here this velocity vector, it can be resolved into two components. One along this direction, that is V sin theta. This is the perpendicular component of magnetic field. Another component that is along the direction of magnetic field, that is V cos theta. Okay, there are two components of velocity. One is V sin theta, which is perpendicular to the direction of magnetic field. Other is V cos theta, which is parallel to the magnetic field. Okay. Then here is a charge. Charge is moving with velocity V in a magnetic field. In this case, there is a force. That force is known as magnetic force. That magnetic force is represented as Fm. Fm is the magnetic force. It is directly proportional to the magnitude of charge. Then it is directly proportional to the perpendicular component of magnetic field, not this component, perpendicular component of velocity, that is V sin theta. Again, magnetic force is proportional to strength of magnetic field V. We can combine together. We can combine these three equations together. We get F proportional to Q V sin theta B. There is a constant. F is equal to a constant K into Q V B sin theta. Just rearrange this equation. Okay. For K is equal to 1, at that case F is equal to Q V B sin theta. Okay. V B sin theta can be written as F is equal to Q into V cross B. In a cross product, V B sin theta is equal to V cross B. What is dot product? How to convert dot product? Multiplied by cos theta. Like this, VB sin theta is equal to V cross B, and theta is the angle between velocity vector and the magnetic field vector. This equation is magnetic force. This equation is the equation for magnetic force. What is the equation for electric force? Electrostatic force, Fe is equal to Q into E. Magnetic force, Fm is equal to Q into V cross B. There are two forces. We can add up these two. We get the net force, that is, net force is F net. Net force is QE plus Q into V cross B. This equation is known as the equation for Lorentz force. This equation is the equation for Lorentz force. Lorentz force. There are two parts. It is Lorentz electrostatic force. It is Lorentz magnetic force. Who is Lorentz? Lorentz was a Dutch physicist. He postulated the existence of electric charges in an atom. For this he was awarded a Nobel Prize in 1902. This equation was first given by Lorentz, H.A. Lorentz, Heinrich Andrew Lorentz. Okay, therefore this equation is known as Lorentz force. At the beginning I told you that we can find out the direction of electrostatic force for positive charge and for negative charge. Therefore, we can find out the direction of magnetic force. The direction of magnetic force can be explained on the basis of right hand palm rule. How to identify the direction of magnetic force? The direction of magnetic force can be explained. The direction of magnetic force can be explained on the basis of right hand palm rule. Right hand palm rule. Okay? The direction of magnetic force can be explained on the basis of right hand palm rule. What is right hand palm rule? This is my right hand. This is my thumb, 4 fingers, and this is my palm. You can see. Okay? This is my palm, my thumb, 4 fingers. Here, according to right hand palm rule, the thumb indicates direction of velocity of positive charge. Thumb indicates direction of velocity of positive charge, and 4 fingers indicates direction of magnetic field, and perpendicular to the palm, which indicates direction of force. Okay? This rule is used to find out the direction of magnetic force. For example, consider a charge plus Q which is moving in this direction, velocity along this direction. And the magnetic field can be in this way, that is cross. What is cross symbol? What is the importance of cross symbol? Cross symbol means magnetic field lines into the plane of board. This is a plane. Magnetic field lines into the plane of board. We can apply right hand palm rule like this. This is my 4 fingers into the plane of board. My thumb indicates direction of motion like this. Can you see? Direction of motion. My palm points in the upward direction. Palm points in the upward direction. That is, in this direction we can the magnetic force. The direction of magnetic force along this direction. Okay? What is right hand palm rule? What is the importance of right hand palm rule? Right hand palm rule is used to find out the direction of magnetic force for a positive charge. Suppose it is a negative charge, what will happen? Suppose it is a negative charge. What is the direction of force? Direction of force is the opposite to the direction of force due to the positive charge. That means along this direction. For positive charge it is along this direction. For negative charge it is along this direction. That is opposite to the direction of positive charge. Okay. So this chapter is mainly discussed about moving charges and magnetism, or relationship between moving charges and magnetism. Our first topic is Lorentz force, Lorentz electrostatic force and Lorentz magnetic force. And the equation is F is equal to QE plus Q into V cross B. V cross B can be written as VB sin theta. There is an angle theta. Theta is the angle between V and B, velocity and magnetic field. This equation is known as equation for Lorentz force. Then the direction of magnetic force can be explained on the basis of right hand palm rule. Okay. Thank you for all. Take care. Namaskar.